To the series. This is one where they will ask us to either find the radius of convergence or the interval of convergence of the power series. So where is that convergence happening and how much of the series is converging? We saw when we did the activity, I think it was last week, right? Where we could get the sine and the polynomial to match up. But how much of that is matching up, right? That's what the radius and the interval are, is how much of that is the same, okay? All right, so I want you to take a minute and just skim through from where it says power series all the way through the box, okay? They were all on the buildings. They were trying to get warmth or something. I don't know. I'm just glad there weren't as more because they cut that field down this week, right?
Oh, yeah.
So,
There was a bunch of dead corn across from the popcorn, and then they cut it all down.
yeah, so I'm surprised there weren't more.
It was all dried out.
Okay, it's to feed cattle or something, animals. All right, so there is a new word here that I neglected. The power series. What you've been working with everything that's power series, right? Because they're all powers and they're in a series, right? So this thing that we have, this estimate for E, is called a power series for E. So if you see the terms power series, you are, that's all that they're meaning, is just this series. And sometimes I'll start calling it the designer series when we get into the ones that we have to memorize. Okay, or if we do memorize them, they're a lot easier. Okay. It's really just a good old Taylor-Maclaurin. They break it down a little bit less than the Taylor-Maclaurin. It's just in general power series, okay? It's still centered at C just like it was before. So if I was gonna write, this was like x minus 2 to whatever the n power, what would you tell me the center is? Yeah, it would be 2, right? Remember, we change that sign in there for the center, okay? And notice the center is in there every single time for our expansion for every single term, okay? All right, so sometimes we have to do a little bit of work to find the center. All they're asking us to do is state the value of C where the power series is centered, because that's part of understanding how big the radius is and how big the interval is understanding where the center is, okay? I'm going to rewrite this one just a little bit, okay? So I'm going to rewrite it as x plus 0 to the n power over n factorial. Which, it's a Maclaurin, right? Probably. So what's my center at in that one? 0, right? I'm adding 0. I purposely put the 0 in because there wasn't anything with the x, right? I didn't have to do that. I could have recognized it was 0, but I just wanted to make sure we were clear on it, okay? All right, looking at B, okay, again, I'm looking at this piece right in here, right? That repeated piece, that center's hiding in there, okay? Does anybody have any idea what they think the center is on that one?
-1.
Good job. Why -1?
The formula said x minus c, and then the power series is x plus 1, so it will cancel out.
Yep. Good job, Devon. Give Devon pizza and he participates in class. I know the trick, right? Yeah, okay. He's not yet. I know the trick. We got to give Devon pizza every day now, so he'll participate in class. Okay. So he's completely right, okay? This formula here says we've got to do minus, right? We have an opposite sign, and we had a plus here. So it was like a minus minus, and the C came from that minus sign right there. You guys, it's really important that to do that interpretation like that, you might have to do that if you end up in a college math class, whether it's an algebra or a calculus or whatever. You might have to look at the book, the text, and be able to interpret what it says. That's why I go into those details, okay? All right, any questions on A and B? All right, I want you to find the center on C. I'll give you 10 seconds. Identify the center on C. All right, what did we write down? 1. Yeah, there was no sign change. Like there was a negative, so we know it was already kind of in the right format. That was C equals 1. Okay, so we understand center. Okay, we're going to talk now about the radius and interval of convergence a little bit more. Okay, I am going to give you about 2-3 minutes. I want you to read through it, right? I want you to read through it once on your own, and then we're going to talk about it. Okay, it's okay. I know it looks scary.
No, I don't understand how you found the center of the other one.
Because the formula said the center is center at C, right? And the formula is x minus c. We good on that? All I had to do was change the sign, right? If it's a negative, my center is a positive. If it's a positive, my center is a negative. Is that better, Annalisa?
So it just switches signs?
Switch the sign. Unless there's nothing adding to it, then it's a 0. Okay? Are you good? Okay. All right, everybody's reading through this chunk right here for me, okay? I'll give you like 2-3 minutes. Especially the box. The box is super important. I'll give you about 20 more seconds to read it. Okay, so this interval and radius convergence stuff has 3 different scenarios, right? Okay, and that's what it's talking about in the box. All right, so let's go back and talk about the picture of what's going on. Okay, so just so you understand one more time. Okay, so I have got some function, right? And I'm using something to estimate that function. In this case, I'm just going to use a line, but a lot of times we use a polynomial to estimate. Okay. So we're trying to figure out how much of this is the same, okay? So it might be just the same in one point. It might be the same in an area, right? It might be the same in an area, or it might be all the same. Okay, those are the 3 possibilities. So it could be a single point. It could be an interval. It could be the entire real line, okay? So it says this in words right here, okay? So if the series only converges at C, it only converges with the power series in the original at that one single point, this would be a scenario where our radius of convergence is equal to 0. And when we talk about, and they talked about that here, right? Radius of convergence equals 0, okay? If it only converges at C, that means it diverges everywhere else. So if we're doing one of our series tests, which we're going to be doing again today, I told you the ratio test was coming back, right? It would mean it would diverge by the ratio test, okay? And our radius would equal 0, okay? In the next scenario, it has an interval where it converges on. So this is talking about convergence of an interval here in number 2, okay? This is the scenario we end up with most, okay? Is that one in the middle, okay? It says that it converges absolutely when it's less than the radius, and it diverges when it is greater than the radius, okay? All right, if we have that it converges at the series converges absolute for all x, so it just converges for all x, then that means our radius is equal to infinity. Okay? And that's, it told us that here too. Series converges for all x, the radius is equal to infinity. Okay? And then it gives us the definition of interval of convergence. So the set of all values for x for which the power series converges is the interval of convergence. So what they're talking about, a radius versus an interval. Okay? The radius is just the length from the center out. The interval is both radii in both directions. So that's why there's a radius versus an interval. A lot of times they want the interval, okay? But you never know, so we're going to do them both, okay? All right, let's see, 20. All right, see if we can get through 2 or 3 examples, okay? That's our goal. These first 3 would be a good stopping point because the endpoint convergence starts getting longer, okay? So let's see if we can get through the first 3, okay? So example 2, finding the radius of convergence. Find the radius of convergence of each power series. So all we're doing is dealing with the radius piece, okay? So I need to get it into this format here, this x minus c format, okay? The way that I'm going to do that is I am going to use a ratio test, okay? So we're going to use a ratio test. That's what I would put out here. That's not how. Use ratio test, okay? Well, I believe one of the AP exams that I graded, it was the one that I actually went to Kansas City for, okay? I spent like 8 hours a day, and we had one of the 4 parts was either finding the radius or interval, and I had to grade the ratio test over and over and over because everyone used the ratio test for all 3 parts, even though they only needed it for 1. So, very useful test. Okay, we're going to put this in the ratio test, okay? There were a lot of 9s. We made a game of it, and if you got a 9 points out of it, you would have to say something that like had the number 9 in it. I don't know, but like it would be like the team, the football team in San Francisco is the 49ers, and so you had to have. It kept morphing into different things because we were so bored grading tests. Our brain was thinking about what would the next thing we would say what 9 would be while we were trying to grade the test. It was very sad. All right, and I missed Father's Day that year too. So it was a math. It was basically a math teacher sweatshop. That's what it was. It totally was that. And but then bio was next to us, and then I think pre-calculus was down in the nice rooms, and then I can't remember where else. Who else was there? I think.
That's what it sounds like. She's like, there's no windows.
That's what I'm saying. No windows, probably a door. And you just
It hailed one day when we were in this building, and it was like a metal kind of roof, so it like sounded really bad. Yeah. All right, it pretty much was. Okay, let's keep going. We're gonna get through 3 problems. Okay. All right. So the limit as n approaches infinity. If I'm doing the ratio test, okay, what am I supposed to plug in? We got to remember. Good job. We got to plug in n plus 1. So I'm gonna go n plus 1 factorial x to the n plus 1. And then we're supposed to divide that by the original. Since we don't have a fraction here, I'm just going to go ahead and divide by the original rather than doing the flip and multiply, right? So n factorial x to the n. All right. I'm going to go through my steps. I'm going to expand and cancel. So limit as n approaches infinity. All right. What would I expand n plus 1 to? Good. N plus 1 and n factorial. Perfect. Okay, and then x to the n plus 1 is going to get split up into what?
X to the n, x to the 1.
Yep. And then on the denominator, I have n factorial and x to the n. All right. We are going to do some crossing out. What do I get to cross out? Good. Perfect. Okay. Then I'm gonna simplify this a little bit. I get the limit as n approaches infinity of n plus 1 times x. This does not look like a straight enough line. Okay. I'm gonna go ahead and apply my limit. Okay. What is the only variable I am plugging in for that limit? N. So I'm plugging in n into the n plus 1, or plugging in infinity into the n plus 1. which would be infinity plus 1 times x. What's that going to be? It's going to be infinity. Okay? So, according to the ratio test, if I equal infinity, do I converge or diverge? So I diverge, so therefore it diverges. If we end up with something that diverges, what's the radius? The radius is 0. Okay? All right, so therefore the radius of convergence is c equals 0. Not c, sorry. R equals 0 for radius. So if I get diverges off of a ratio test, no interval, the radius is 0. Okay? It only converges at the single point.
And if it converges, would it be
We're going to keep going. Yeah, we're going to see some that converge. Okay, I'm going to do a little bit of everything. Okay? All right. Any questions on A? All right, let's look at B. Or look, sorry, not look at B. It is B.
No, nobody jumps with the fly swatter.
All right.
It is a fly thing.
So we're going to do, it says find the radius of convergence again. Okay. I am always going to use the ratio test. So if you did not learn the ratio test for the last quiz, you need to learn it for the next one. Okay. You do not get out of it. All right. What am I supposed to plug in? N plus 1. Okay. I want you to try that part. Just get that part written out. I'll wait like 10 seconds before I start writing it. Do n plus 1 over the n. Okay. Don't forget your limit out front.
I know. As soon as she said it, I was like,
Okay, let's take a look. We should have that, right? What can I cross out right away? 3 goes away. Might as well not write it again, right? It's Friday and we're lazy. All right. Could I break this guy up just like I broke up the x to the n plus 1 on this one?
Yeah.
Okay, so we got to look for those opportunities, right? To use our algebra in a different way. So I've got x minus 2 to the n, x minus 2 to the first over x minus 2 to the n.
So wait, I have a question.
Mm-hmm.
So when it's like just how the original problem is, how do we put it into a fraction? Do we just put n plus 1 on the top and then n by itself on the bottom?
Yes.
N plus 1 on top and then the original.
Yeah, when the original ratio test said I have to do the n plus 1 on the top and the n on the bottom. All the ratio tests we saw in the first part of the unit were always a fraction, so we did the original and flip and multiplied the second one. Okay, does that make sense? All right, so we're slightly different version. It's okay, we're good.
Just write the same thing, just.
Yep, with the n plus 1 on the top and on the bottom. Okay. All right, what gets to go away?
And
Yeah, x minus 2 to the n. So let's write down what's left. We have the limit as n approaches infinity of x minus 2. There's nowhere to plug in, so guess what? That's the limit. The limit is the absolute value of x minus 2. Because there's no n to plug into. All right. So we know that it has to converge, okay, on that, right? According to the ratio test, if we were going to go flip back a few pages in our notebook, we know the ratio test converges when it's less than 1. Okay, in fact, it might have said, did it say that up here? No, it just said R. Okay, but we know that the ratio test converges when it's less than 1. So I'm using this is part of my ratio test stuff. Okay. All right. So I'm going to actually we're going to sort of get the interval here. I'm going to get rid of the absolute values. To get rid of the absolute values, do you remember what we have to do? Split it into a. Not enough of you had me for algebra 2 trig.
that was like, I had handy.
You had to split it into a positive expression and a negative expression. So we're going to do that same concept, except that we're going to do a negative one and a positive one. That's how, I don't know what I wrote the bar, I'm done. So that. So now I have an interval, right? That's how I take absolute value bars off. So it's always going to be less than 1 because of the ratio test, okay? I'm going to split that off. Now.
Wait, really fast.
Mm-hmm.
I don't understand how you got rid of bars. Yes, you put the -1 and the 1, but I don't understand how that makes sense.
Because I know that if I'm less than 1, that means that if I'm the absolute value less than 1, right? So I'm here, right? So if my absolute value is less than 1, it has to be somewhere between those two numbers, right? Because from here to here is 1, and from here to here, that distance is 1.
Oh, I remember
But
this.
doesn't absolute value mean that it's going to be positive?
It just means that the distance is 1.
Oh, the distance.
The
between the two
distance is 1. So even though it's a negative number, the distance between -1 and 0 is still 1.
points, still one.
Okay, does that make sense?
Yeah.
All right, that was a really good question.
Would x equal 2?
Huh?
Would x equal 2?
No, it does not equal 2. Okay, so I have to I'm not done solving this yet, right? So I'm going to take this -2 and I'm going to solve, but I've got two equations there, right? I've got one on either side. How do I move the 2? Add it. So I'm going to add it here and here. That's a little bit different. We haven't probably done that algebra, because this is not typically the way we would show it to you guys. All right, what's -1 plus 2? 1. And then what is 1 plus 2? 3. That's actually your interval of convergence. It's going to converge between x equals 1 and x equals 3. But the question asked for interval of convergence. What did it ask me to find? The radius. So how big is that interval? Well, how big is it from 1 to 3? 2. So I know that my interval length is 2. Okay? So how do I get the radius length out of that? Think of the interval like a diameter. What would I have to do to get a diameter? Or sorry, to get a radius from a diameter? Yeah, we gotta cut it in half. So we're gonna divide that by 2. So my radius length is 1. So think of it, from the center out to one of the edges, it's 1. Tony asked if x equals 2. X doesn't equal 2, but what does equal 2? What do we call it? I think you were on the right track, Tony, and I said no. The center is 2, right?
Why did you divide over 2 though?
Because I knew my center was 2, right? My whole length of the interval was 2, right? And I needed half of it to get the radius, because I'm talking about from here to here is the radius value. Okay, so I had to cut it in half.
So basically just
Divide the interval length by 2, that gives you the radius. Okay? Good, we have time for one more. All right, so we've now seen scenario 1 and scenario 2 up here from the box, right?
How would we write the therefore?
All you would just do is, I would say, therefore, the interval of length 2 and the radius is length 1.
Oh, okay.
Okay, yeah. Because we forced convergence, right? Right here in this line, we forced convergence by ratio test. Okay? Which you're going to have to do that somewhere on the AP test. Okay? It is by definition of the ratio test that absolute value converges as long as it's less than 1. Okay? Any other questions? Okay, we've seen scenario 1 and scenario 2. Guess what's coming? Scenario 3. Okay? Didn't you want to go to council? Or didn't you have to go to somewhere? Or did you just skip it? Okay.
I don't have to go here.
That's fine. I don't care. I'd rather you stay. But okay, let's look at this next one. If I am doing the ratio test, am I concerned about the -1 to the n power? No. Okay. What do I have to plug in? N plus 1. It's going to be a little bit more challenging this time, right? Okay, so I'm going to write it down here. The limit as n approaches infinity. All right, so I'm going to go x to the 2 n plus 1 over 2 n plus 1 factorial. Now this is the case where we were when we did ratio tests in the first part of the unit, right? I just have the plus 1. What do I have to do with the original? Yeah, multiply by the reciprocal. We're going to keep flip change, or keep change flip, or whatever the heck it is. Okay. We were doing that in trig yesterday, so because we're doing rational expressions right now. So x 2 to the n or 2n plus 1 factorial over x to the 2n plus 1. Okay. I'm going to rely on instinct a little bit, right? What are we going to do with this 2? We're going to distribute there, distribute there. So I have the limit as n approaches infinity of x to the 2n. When I do 2 times 1, what do I get? Plus this 1 at the end would make it 3. So I'm going to get that in both the numerator and the denominator stuff, right? So all I did with that second term is just rewrite it. I wasn't ready to mess with it yet. Okay. All this is complicated, or it's yucky algebra. It's not even that complicated. It's yucky algebra. Okay. All right, we got to break it up a little bit, right? We got to expand so we can get rid of some stuff. All right, so how am I going to break up the x to the 2n plus 3? X to the 2n, x to the 3, okay? I'm going to keep that factorial there. So 2n plus 1 factorial. I'm going to expand this guy, okay, until I hit this one, right? So that's going to be 2n plus 3. What comes before 2n plus 3? I'm not there yet, right? So what comes before that?
1.
Good. So now I'm there, right? So this became this. All right, how do I rewrite the x to the 2n plus 1? How do I write the x to the 2n plus 1? Good.
Why is there still a factorial on the bottom?
Because I don't know where that ends, right? I always have to have a factorial when I expand. Typically, it's just been an n factorial. But notice, it's going to cross off with the one on the top. So you're trying to get it to match the one on the top. So you keep going, and you stop when you hit the one that it's going to cancel with. Okay? All right, what can I cross out right away? Okay, and the 2n plus 1 factorial. Is there anything else that I can get rid of? Yeah, we could do, what would these guys become?
X squared.
Good, x squared in the numerator. So I've got the limit as n approaches infinity of x squared over 2n plus 3 times 2n plus 2. Okay. If I think about what's going on here now, okay? No, because it canceled in that last one. Okay. All right. What am I supposed to do with that infinity now? Plug it in. What's it going to make both of these things? It's going to make both of them infinity. So I've got x squared over infinity times infinity. What's that going to make equal? 0. Okay. When it converges, how? Do we remember? It converges absolutely in a ratio test. And that's something we just got to go back in and relearn, right? We should have probably looked at our ratio test rules, okay? When I converge absolutely, so therefore converges absolutely, okay? That means your radius of convergence is r equals infinity. So if it converges absolutely, that means it converges everywhere. It was a good polynomial. It's a good estimate. Okay. All right. Are there any questions?
Could alternating series work on this?
Could alternating series test work on this? We don't typically use the alternating series test on these. It's always ratio test. Okay. Could I use that? Could I alternating series to actually determine convergence? Probably. But we've got the factorial, which would lend it to ratio, right? Yeah. It's harder to tell what happens with that in alternating. Okay. All right. Are there any other questions? All right. We're going to stop there. If you need another piece of pizza or you didn't get your cupcake, okay, or you need another soda, please take it, okay?